This is Edexcel's Mathematics Practice Set 5, Paper 3H. Question 1. Find the gradient of the straight line. The gradient is given by the difference in y divided by the difference in x. So if we find a point where it crosses, so we can read off easy, go across and go up, the change in y is 3, the change in x is 2, so the gradient would be 3 over 2, or 1.5. Question 2. Helen went on 35 flights in a hot air balloon last year. Draw a frequency polygon to show this data. So for a frequency polygon, we always plot the midpoint of the group. So for the first one, we'll be plotting between 0 and 10, which is 5. Between 10 and 20 is 15. Between 20 and 30 is 25. 30 and 40 is 35. 40 and 50 is 45. So the first point I'll plot is 5, 6. So go to 5 along the bottom and up to 6. That's my first point. Next one will be at 15, 9. So go to 15 along the bottom and then up to 9. Next one would be 25, 8. So 25 and then up to 8. 35, 7. Which would be there. And finally 45, 5. Which would be there. Finally, with a frequency polygon, we join each of the crosses together with a straight line. So always use a ruler with this. It's not a line of best fit, that's for a scatter graph. So your frequency polygon should look like that. Question 3. Henry's thinking about having a water meter. These are the two ways he can compare. So he can either pay for the water that he uses, or he can pay £107 a year. So we just need to look at how much it would cost him using a water meter. So first of all, it says he uses 180 litres a day, so we want that in a year. So there are 365 days in a year. So 180 times 365, that would give us 65,700 litres per year. It tells us that 1 cubic metre is 1,000 litres. So if we divide that by 1,000, 65,700 divided by 1,000 would be 65.7 cubic metres per year. It then tells us that the cost of each cubic metre is 91.22 pence. So if we do 65.7 times 91.22, that will give us 5,993.154 pence per year. Now if we put that to pounds by divided by 100, that would be 59.93 per year. However, there's also a standing charge per year, so we need to add on to that the £28.20, and if we add that all together, that gives him £88.13 per year. So on a water meter, it costs him far less, so we should put, he should stay on a water meter. Question 4. Kalinda pays on tariff A for the number of units of electricity she uses. Kalinda uses the graph to work out how much she pays each month. How much does Kalinda pay for each unit of electricity she uses up to 60 units? Well, if we go to 60 units on the graph, up to the graph and read off, we can see that that's at £15. So £15 for 60 units. We want the answer in pence. So if we write £15 in pence, that would be 1,500 divided by 60, and that would give us 25 pence per unit. It says Kalinda should change to tariff B. Here is the monthly charge for tariff B. So 20 pence per unit of electricity charged. On average, Kalinda uses 90 units of electricity each month, and she wants to pay the least amount of money. Which should she do? Well, if we do 90 lots of 20 pence, then that would give us 1,800 pence, or £18, if she's on tariff B. So that's for tariff B. For tariff A, we can use the graph. So if we go to 90, read up and read across, we can see that tariff A would be £19. So yes, she should go to tariff B. Question 5. David is planning his garden. There'll be 2 paths in the garden. The rest of the garden will be grass. All the measurements on the diagram are given in feet. Now, just the fact that it's in feet doesn't matter, it just means your final answer will be in feet squared rather than metres squared like we used to. So give the total area of the grass. So we've got three parts of the shape that are grass. So the first shape is a triangle, so we do base times height and half it. So for shape A, the base is 12, the height is 25, and we need to half that using a triangle, which will give us 150 feet squared. Part B, again, base times height, so that'll be 11 times 25 and half it, and that gives 137.5 feet squared. And part C is just trapezium. Now, the two parallel sides are the 6 and the 15. So we need to do 6, add 15 and half it, and times by the distance between them. That's the formula for a trapezium, which will give us 262.5 feet squared. And if we add all those together, we get the total area of grass. That is 550 feet squared. Question 6, simplify p to the power 5 times p to the power 4. Well, that would just be p to the power 9. Q to the power 5 divided by q squared would just be q to the power 3. We subtract the powers when we're dividing. Simplify 12tu to the power 6 divided by 6tu to the power 5. Well, if we write that out as a fraction, it makes it a little bit easier to see. So I would prefer to write it out like this. And we can see then that the 6 will cancel with the 12 to become 2, because 12 divided by 6 is 2. The t will cancel with the t, and then u to the power 6 will cancel with the u to the power 5, just to leave the u on the top. So the answer would be 2u. Simplify 9w squared y to the 6 to the power of a half. Well, the power of a half means to square root it, so we just need to square root each term. So the square root of 9 would be 3. The square root of w squared would just be w. And the square root of y6 would just be y3, because y3 times y3 will give you y6. For x is greater than 1, write the following expressions in order of size. Well, it's really important that x is greater than 1, because when you multiply a number that's greater than 1 by itself, it's always going to be bigger, so that's really important. So if we start at the first one, x to the power 0, anything to the power 0 is always 1. X squared is obviously going to be bigger than x, because you multiply it by itself. So x squared and x squared will be bigger than the next one. X to the minus 2 means 1 over x squared. So again, that'll be a fraction, so that's going to be less than a whole one. So that'll be less than x. And x to the power of a half means the square root of x. So even though it's greater than 1, it'll be more than 1, but it will be less than x. So if we put those in order, the smallest will be x to the minus 2, because that'll be less than 1. Then we'll have x to the power 0, because that will be 1. Then we'll have x to the power of a half, because the square root of a number greater than 1 is always smaller than the number itself. Then we'll have the number itself, and then we'll have x squared, because that will always be bigger than x. Question 7. The volume of cube B is 20% less than the volume of cube A, and the volume of cube C is 20% less than the volume of cube B. Cube A has a volume of 8,000 centimetres cubed. What is the volume of cube C as a percentage of A? Well, if A has a volume of 8,000, B would be 20% less. So to find 20% reduction, you would times by 0.8. So that will give you the volume of B. And then we want to do a 20% reduction on the volume of B as well. So we times that by 0.8. This would be the same as doing 8,000 times 0.64. So a lot of people would now try and work that out and then put it as a fraction of 8,000. But 0.64 is just the percentage decrease, so the answer is just 64%. Question 8. In a sale, normal prices are reduced by 15%. So straight away, to reduce by 15%, we do 100% minus the 15%. So we would want to be finding 85% of the price. It says Janice buys a computer in the sale and she pays £578. What was the normal price? Well, if we knew what the normal price was, we'll call that x, you would multiply that by 0.85 to get the sale price. So the sale price is 578. So to work out the original price, we do 578 divided by 0.85, and that will give us £680. Question 9. Some trains from Manchester to London were late. The incomplete table in histogram gives information about how late the trains were. Use the information in the histogram to complete the table, and then use the information in the table to complete the histogram. Well, on this question, we always want to look for a bar and a complete set of information from the table. So if we look, the first row is complete, as well as the second row. but only the first bar is complete. So we're going to be looking at the first bar and the first row to find out what the frequency density is. To work out the frequency density, we always do the frequency divided by the class width. So the class width for this one is 5. So we want to be doing 16 divided by 5. So we know that the frequency density should be 3.2 for that. So we can tell that this here is 3.2. Using that, we can tell that each large square must therefore be 0.8, because it will go 0.8, 1.6, 2.4, 3.2 and so on. The frequency density of the second bar then is, again, we've got a class width of 5, so we want to do 10 divided by 5, which would be 2. So we can put that second bar in now, so 2 would just be here. We can use the third bar to work out what the frequency should be for the third section. So the height of that third bar is just there, and that is about 1.2. So we want to be doing 1.2 times the width of the bar, which is 10. So that will give us a frequency of 12 for that third bar. Again, we've got the fourth bar, so we can use the height of that. The height of that is 0.6. So we want to be doing 0.6 times the width of the bar, which again is 10. So that will give us a frequency of 6. And finally, the last bar we need to draw on. So we've got a frequency of 8. We want to divide that by the class width, which is 20. 8 divided by 20 is 0.4. So we want to do a bar that's 0.4 tall and also runs to 50. So 0.4 tall and runs to 50. That's where our third bar would be. Question 10. Make x the subject of y equals the square root of 2x plus 1 over x minus 1. Well, what we want to do here, we want to unpick all of what's happening to x. So the first thing we're going to do is we're going to square both sides to unravel that. We then want to get all the x on the same side. So at the minute we don't want a fraction. So we're going to take the x minus 1 to the left, and we'll have y squared brackets x minus 1 equals 2x plus 1. If we expand those brackets, we'll have x y squared minus y squared equals 2x plus 1. If I go up here, this gives me a bit more space. From there, we want to get all the x on the same side. So if we keep the xy squared where it was and take the 2x over, it becomes minus 2x. On the other side, we had a 1, and I'm going to take the minus y squared over and it becomes a plus y squared. To get x on its own, we now need to factorise the left-hand side. So take x out as a factor, you have y squared minus 2 equals 1 plus y squared. And then to get x on its own, x has been multiplied by those brackets. So we'll take the entire bracket down on the other side and the y squared minus 2 on the other side. Question 11. Calculate the length of BC. So BC is this here. I'm going to call it A. The reason I'm calling it A is because when we've got a side, an angle and a side together like that, we're going to be using the cosine rule. So the cosine rule is A squared equals B squared plus C squared minus 2BC cos A, where A is the side that we're after and big A is the angle opposite it, so the 120 degrees. So if we put all that information in, always write down what you're putting in. So the two sides, B and C, will be these two. So we can call it, sorry, they're the opposite way around, because the diagram's always labelled. It actually doesn't matter which way around they are. So 5 squared plus 6 squared minus 2 times 5 times 6 times cos 120. Now you can just put all of that into your calculator, but don't forget that gives you A squared. So we want to do the square root of all of that. If your calculator has a square root button that takes the square root over all of it, then we're okay, but otherwise you need to put all of that in brackets. And that will give you 9.539, so three significant figures will be 9.54. Question 12, triangle P is drawn on a coordinate grid. The triangle P is reflected in the line x equals minus 1. So x equals minus 1 is this line here. So you can see it's 2 squares away, so I need to go 2 squares away this side and reflect it out, so it will go to there. And then reflecting the line y equals 1. So y equals 1 is this line here. So it's 1 square away, so if we reflect that down, that will go to there. It says describe fully the single transformation that maps P onto Q. So this shape here is the Q. So we can see that it's been a rotation round to here. So straight away we get the first mark for putting rotation. It has been 180 degree rotations, because 90 degrees will get it into this quadrant, so 180 will get it into this quadrant. So with 180 degrees we don't need a direction. And we can see that the centre of rotation will be where the two lines cross, so about -1, 1. Question 13. A machine part is made by cutting a small square from the centre of a large square, and the dimensions are given, but it's all in algebra. It says the perimeter of the small square is 2/3. That's really important, the perimeter of the large square. Work out the length of the side of a small square. So we need to work out the value of x. So the perimeter of the large square, if we add all those up, each side will be 3x plus 4, so we'll end up with 12x plus 16. And for the small square, you'd end up with 4x plus 16. Now, it says that the small square is equal to 2/3 of the large square. So we can set up an equation like that. Now, normally I would say find 2/3 of 12, which we can do, and 2/3 of 16, but 2/3 of 16 is a difficult number. So this time I'm going to say the 3 is dividing the 2 on the right hand side, so if we multiply by 3, we can change that and take it on the other side and have that. So leave the 2 where it is. Expand those two sets of brackets, we end up with 12x plus 48 equals 24x plus 32. If we take 12x off both sides, because we want to get rid of the smallest amount of x's, we'd end up with 48 equals 12x's plus 32. Then we want to take 32 off both sides, end up with 16 equals 12x. Divide by 12, we get x equals 1.3 recurring, or 1 1/3. So we now want to work out the length of the small square. So the length of the small square is x plus 4. So substituting 1 1/3, or 1.3 recurring, into that, we will get 5 1/3 centimetres, or 5.3 recurring. Question 14. F is inversely proportional to the square of x. When f is 0.8, x is 5. Find a formula for f in terms of x. So f is proportional to the inverse of x squared. So that's how we want to start off. We then want to find out the constant of proportionality, so we put k in. We then add values for f and x, so we could put 0.8 equals k over 5 squared. 5 squared is 25, and if we rearrange that, it's divided on the right hand side, so it will multiply by 25 on both sides. We get 25 times 0.8 will give us k. So k would be 20. It then says, a lot of people just stop there, but it says give us a formula for that. So we need to put k is 20 back into this. So our formula would be 20 over x squared. Work out the positive value of x for when f is 320. So if f is 320, that will give us, put that into the formula, we get 320 equals 20 over x squared. Take the x squared up because we don't want that on the bottom, so it will multiply on the other side, so we have x squared times 320 equals 20. So x squared will be 20 over 320, and we want to find the square root of that to find x, and the square root of that is a quarter. Now, it could be plus or minus a quarter, but it asks for the positive value. So remember, when you square root something, it's always plus the number and minus the number, but in this case, it's just the positive value. Question 15. Here's a parallelogram, work out the area of it basically. So to work out the area of a parallelogram, we do the base, which is 7, times the height. Now we don't have the height at the moment, so we can work that out because we've got a right angle triangle here, because the height is always straight up, and we've got an angle of 40 and a side of 5. So in that triangle we have got the hypotenuse, and we'll call this the opposite, even though I've called it the height so far. So if we've got the opposite and the hypotenuse, we're going to be using sin. So sin 40, using trigonometry, equals the opposite, which we called h over 5, because we're after the height. Rearrange that, we need to do 5 times sin 40 to work out the height. which is 3.2139 and so on. Now just leave that in your calculator, because to work out the area we just need to multiply that by 7. So multiply that by 7, we get 22.5 centimetres squared, correct to one decimal place. Question 16. Clive wants to estimate the number of bees in a beehive. Clive catches 50 bees from the beehive and he marks each bee with a die, and he then lets them go. The next day he catches 40 bees and 8 of them have die. Work out an estimate for the number of bees in the beehive. Well, on the first day he marks 50 out of a number of bees in that beehive, which we don't yet know. On the second day, 8 out of the 40 bees he catches have die on them. So the two proportions should be the same as an estimate. So rearranging that to find x. First of all, if those two are the same, we can flip them, find the inverses, and those two will also be the same. So we can just find the inverses of both. It just helps us rearrange it a little bit easier. So x would be 40 over 8 times 50, which will give us 250 bees in the beehive. It says write down any assumptions that you made. Well, if he was selecting bees, then that would alter what we've got. So we need to assume that he's taken a random sample on the second day. Question 17. A new shopping centre is opened and 500 new jobs are created. After 2 years, the number of jobs has increased to 700. Assuming that the number of jobs increases exponentially, work out how many jobs will be after 5 years. Well, a lot of people have been asking me about the exponential questions. Basically, it's very similar to the compound interest questions. So, right at the start, there were 500 jobs. If that's increasing exponentially, it just means you are increasing by the same multiplier each year. So after 1 year, you would multiply that by x, and to get after 2 years, you multiply that by x again, or x squared. And that will give us an answer of 700 jobs in the second year. So to rearrange that, we'd have x squared equals 700 over 500, and to work out x, we do the square root of that. 700 divided by 500 is 1.4, so it's the square root of 1.4. That's the multiplier that we use each year to find the number of jobs. So at the start, there were 500 jobs, and each year you would multiply by the square root of 1.4 to find how many jobs you had the year after. So after 5 years, we do that to the power of 5. So altogether, that will give us 1159.55 jobs. So we'll round that up to 1,160 jobs after 5 years. Question 18. Write as a single fraction in its simplest form, 2 over x minus 4, take away 1 over x plus 3. Well, to add or subtract fractions, we need a common denominator. So to find a common denominator, we can multiply together the denominators of each of those. So we want to multiply the top and bottom by x minus 4 and x plus 3. So we'll be doing, if we multiply the first one by x minus 4, x plus 3, then the x minus 4 will cancel out to the top, and you'll have x plus 3. And if you take away from that, multiply top and bottom this one by x minus 4, you'll have one bracket x minus 4, and we'd have x minus 4 over x plus 3. Now we've got a common denominator, we can just expand the tops. So we'd have 2x plus 3, sorry, mistake there, 2x plus 6, don't forget to multiply both numbers. Take away, and then minus 1 times x is minus x, but minus 1 times minus 4 is plus 4. Be very, very careful with that bit. And that would all be over x minus 4, x plus 3. And just to simplify that too, 2x take x is just x, and plus 6 plus 4 is plus 10. And that would all be over the common denominator of x minus 4 and x plus 3. Question 19. Namusa has 30 sweets. She has 18 fruit sweets, 9 aniseed sweets and 5 mint sweets. She's going to take 2 sweets at random, work out probability will not be the same. Now, if we do a probability tree for this, so if we have fruit sweets would be 18 over 30, the aniseed sweets would be 7 over 30, and then the mint sweets would be 5 over 30. Now it says work out probability of not being the same. Well, you can see we need this branch, this one and this one, this one and this one. And that's a lot of working out to do. So what I'm going to actually do is I'm going to work out the probability of them being the same and take that away from the whole one. So if there's 18 out of 30 when you take a fruit sweet out, that'll mean now there's 17 out of 29 left for fruit sweets. For the aniseed sweets, if there was 7 out of 30 before, once you've taken one out, that'll be 6 out of 29. And then finally, if you take a mint one out, that'll be 4 out of 29 left for there. So, if we multiply down the branches, 18 over 30 times 17 over 29 is 306 out of 870. 730 times 6 over 29 is 42 out of 870. And 530 times 429 is 20 out of 870. And if you add those together, that will give us probability of it of being the same, would be 368 over 870. Now, we're asked for not the same, so we want to do 1, take away the probability of it being the same. Okay, this is just a way of keeping the working out now. So we want to do 1, take away 368 over 870. To work that out, we just do 870 take away 368, which will give us 502 out of 870. If we cancel that down, again this is a calculator paper, so you can put that into your calculator to cancel down. That'll be 251 over 435. Question 20. Solve the inequality x brackets 2x plus 3 is greater than 20. Well, we never want brackets in this, so if we expand that out, we'll have 2x squared plus 3x is greater than 20. We can see that this is now a quadratic, so we always want to solve a quadratic when it's equal to 0. So if we rearrange that to 2x squared plus 3x minus 20 is greater than 0. We can actually factorise that. So you can factorise that to 2x minus 5 and x plus 4. So minus 5 times 4 gives us minus 20. And then just to check, 2x times 4 gives us 8x's, and minus 5 times x gives us minus 5x's, so that gives us plus 3x's. So that does work. So making each of these brackets equal to 0, x would either be plus 2.5 or minus 4. Now, this is an inequality, so you've got to be careful. We shouldn't really use the equal signs. We need to sketch the graph to figure out whether it should be greater than 2.5 or less than, and greater than minus 4 or less than minus 4. So, if we sketch the graph, this is a positive quadratic curve, and it tells us that it crosses the x-axis at minus 4 and 2.5. So, minus 4 and 2.5. That's the whole point of solving a quadratic equation. Now it says that this equation needs to be greater than 0. So we're after all of these solutions here where the graph is greater than 0. So you can see that to be greater than 0, then x has got to be less than minus 4. So x is less than minus 4. And also to be greater than 0 on this side, x has got to be greater than 2.5. So your final answer should be x is less than minus 4 or x is greater than 2.5.